everyone. My name is Ghelmani. I'm a PhD student at Concordia University doing research under the supervision of Professor Amin Hammad. Today I will be presenting on behalf of my colleague Yusheng Huang our latest work titled Digital Twins of Construction Sites, Critical Review and Roadmap. Since the concept of digital twin was introduced, many different definitions have been provided by researchers. For example, one definition considers the digital twin as a virtual representation of a physical system or object. Another definition provided by Bojator, which is more common, considers the digital twin as a system or process that generates and updates a virtual replica that reflects reality and also provides feedback to the reality using different types of analysis and data processing techniques. The benefits of digital twin have been shown in different industries, like manufacturing. These benefits include, for example, visualization during the design phase, collaboration and optimization during the operational manufacturing phase, and prediction and maintenance during the service phase. In this work, we have conducted a literature review to identify the current state of the art in construction digital twin by focusing mostly on its generation and applications. And based on this review, we have identified the current research gaps and will provide a roadmap for future research. In the first step, we collected the papers from search engines like Web of Science and Scopus. After doing an initial review and removing the unrelated papers, the bibliometric analysis was conducted to identify the current trends. In the third step, an in-depth analysis was conducted on the selected papers to identify the current state of the art and also the current research gaps to provide the future research directions. Overall, 35 papers were selected for the in-depth review, and you can see in this figure that the research in this area is growing significantly in recent years. In this slide, we show the distribution of the selected papers based on the journal in which they were published. And of these 35 papers, 8 were related review papers, and 7 provided conceptual frameworks for construction digital twin, and 20 addressed different applications of digital twin in construction. In this table, we can see the other review papers and their shortcomings that led to our own review. These papers either consider generalization of BIM to create and generate digital twin, or consider an application of digital twin in AEC, FM industry, like for example in the design phase or in the maintenance phase. However, no work was done on the application of digital twin in the construction phase, which we addressed in this paper. And in this table, we see the conceptual papers. They address different, they provided conceptual frameworks for different aspects of construction digital twin. For example, different levels of specification or detail, or different ways of managing the data, or the technologies related like blockchain. However, they do not provide like a case study or proof of concept for their proposal. The 20 papers that I mentioned address different applications. Address applications like progress monitoring and quality control, construction safety, construction equipment control, and data management, supply chain management, site measurements, environmental management during construction, and some works also address multiple applications. Based on this roadmap and identifying the current research gaps, we provide the future research direction, and we categorize it into 5 different categories of data collection, data processing, model generation, applications, and some general issues. For each issue, we have categorized the existing technologies into 3 phases. One is take-up phase, which means like the technology is already available and can be applied. The other is the R&D phase, which means like a fair amount of research has been conducted, but to adapt it to the construction digital twin, more research is needed. And the third phase is the emerging research phase, which means the research in this area is relatively new. The first issue was about data collection. In this slide, we provide different data capturing technologies that have either been used by the previous papers in the context of construction digital twin, or can be used and are already available. The take-up phase, which as I mentioned, means the deployment of these sensors in the field. However, the R&D phase includes like providing a concrete way to come up with a plan for sensor installation so that entire construction site can be covered and the data can be provided in a real-time manner from multiple sources. Also, if you choose to use wearable sensors by workers, their privacy concerns should also be addressed. And considering the massive amount of data that is gathered from all different sources, to save this data while maintaining their semantic relationship so that it can be easier to fetch them later, also needs research. The emerging research phase in this area includes using mobile devices like ground vehicles or UAVs to collect and monitor construction sites, and the associated data security and data transmission concerns that these moving devices will have. After data collection is the data processing. The takeoff phase includes using the common techniques that are available, for example, in signal processing, like filtering, smoothing, or using the techniques like sensor-based and CV-based object detection and activity recognition methods that have already been developed. The R&D phase includes scaling these technologies so that they can process the massive amount of data that is produced by construction sites in a near real-time manner, and to also fuse this data from multiple sources and extract knowledge from them using different machine learning and deep learning techniques. The emerging research phase in this area includes addressing the issues that arise with the use of mobile devices, such as doing edge computing, because these mobile devices have limited computing capabilities, or using federated learning to combine the data that comes from these devices and combine them to extract knowledge from it. In this slide, I will explain a bit more about federated learning in the context of computer vision. In federated learning, usually a big model exists on the cloud that can either be developed by a team of data scientists or purchased from the models that are already available. Then this central model can be developed to edge devices, which can perform some data processing or even a small training based on the data that they receive. After that, they will send the result of this processing and training to the cloud to be integrated from the data with other sources. And because in this step only the results are sent, it can help with addressing some data security or confidentiality concerns that are already available. Like there was a talk today about building trust in construction data sharing. And these results can also be sent to the data scientists to further improve the performance of their models, and also sent to the digital twin for real-time monitoring and also to conduct further processing in the digital twin. And also, because a lot of activities, equipment, and operational construction sites are similar across different construction projects, the developed models can also be sold to different projects to further increase the return on investment. After the data processing is the model generation. The takeoff phase for model generation includes creating 3D models based on the point cloud data, like we saw some presentations today about creating a beam from point cloud. The R&D phase, however, includes scaling these projects to provide near real-time, high LOD modeling, and not only include construction sites, but also include construction resources, and even include environmental modeling at different levels of detail or specification. The emerging research phase means because developing a construction digital twin takes a lot of cost and time. So the developed model should be developed in such a way that it can be used throughout the life cycle of a construction site. For example, during the demolition or the construction phase to promote circular economy in the built environment. And also should be developed in such a way that it can be reused in other projects. For example, a platform was proposed with the name of DigitBrain that initialize this mindset to use reusable digital twin. However, it is still in the early phases and further research and consideration is needed in this regard. And also most of the digital twin, construction digital twin works that we reviewed only provide the current and history of the data that they have received. However, to do simulation with the goal of prediction for the service phase is an essential part of a digital twin. So simulation-based construction digital twin should also be considered for future research. Finally, a construction site can be considered as a federated system that is made up of smaller subsystems. Accordingly, a federated construction digital twin should be developed in such a way that it can be built by federating the digital twin of its building components. The papers that we consider that address different applications like progress monitoring, construction equipment monitoring, and site layout. However, some applications still need further research, like productivity analysis, safety monitoring, task navigation, or claim management and supply chain management. Also, in this video, you can see a work that was done by one of my colleagues, Yusheng Huang. This work provides feedback based on the processing in the simulated digital twin environment to the workers for safety issues. And if you remember, providing feedback to reality was one of the main components of the construction digital twin. The emerging research phase can be automating the use of mobile devices so that they can cooperate with based on the activities that the humans and the construction equipment that are performing on the site, so that we will not miss any interesting activities that are being done on the site. Some general issues exist for the development of construction digital twin. One is, of course, the return on investment, considering the large amount of investment that is needed for development of these systems. And the other one is the lack of a guideline or a standard for construction digital twin to align all the efforts that are being conducted right now in this field. And overall, like in this review, we try to identify like the current state of the construction digital twin, and to also provide to identify the current research gaps and provide the future categories for future research. Thank you.